Okay, for lesson 7.2 in Algebra 2, we're going to talk about rational exponents. You've got the word ratio inside of the word rational, and ratio means fraction. So that's really what we're going to see today, fractional exponents. And here's maybe the first definition that we can really jump onto. If you saw the most simple fraction that you could ever have, like 1 over a number, a to the 1 over n, what that's going to mean is you will have a radical. You're going to have a radical. So you're going to wind up with this nth root of a to the first. So the denominator is always going to let you know, the denominator of this fractional exponent will tell you what type of a radical you're really going to work with. So an n in the denominator means we've got an nth root. Now, by way of comparison, what you can also have is if you had a to the m over n, if you had that, what that would mean is you could have the nth root of a to the m, or you could even think of it as the nth root of a all raised up to the m. Both of those forms would be equivalent. So look, number one, super quick problems. Rewrite as an exponential expression. Well, you've got the 7th root here, so we're going to write b, and you're going to see that that 7th in the index is going to go in the denominator. You have b to the 5th, we're going to put the 5 up here. So what you want to definitely hold on to, what you always want to remember, is that that index is always going to be the denominator of your fractional exponent. So as we take a look, say, at letter B, you can say, well, I don't see a number inside of this square root. And what is your index inside there? It's not written, but it's there, though. It's not a 1, it's a 2. It's going to be a 2 there. So this is going to become, and this is x to the first, this is x to the 1 over 2. Okay, so when you have a square root, super important. Remember, it's really going to be an index of a 2. Okay, as you take a look at letter C, as we're looking there, you can see that we have a 5th root of z to the 1. This will become z to the 1 over 5. Z to the 1 over 5 power. Again, just hold on to that very important idea that the index, that number in that little crevice, shows up in that denominator. Here we go with our last one. We've got a 2 inside. Again, a square root always is understood to be written that way. So as an exponent, this would be 14 to what power? 14 to the 1 over 2. It's always understood to be raised up to the 1. Okay? So problems like that, hopefully you can go very fast. Let's change it about a little bit. For number 2, we're going to reverse direction. You're going to be given a fractional exponent, but you need to write it as a radical. So 10 to the 1/3, what kind of a root is it? It's going to be a 3rd root. That 3 is in there, and you could write it as 10 to the 1, but 10 to the 1, of course, is just a 10. So you could, of course, just write it as a 10, and that would be maybe the easiest way we could write it out. We come right here to this 5 to the 1/4. What kind of a root would that be, obviously? It's going to be a 4th root. So 4 goes in that little crevice right in there. You'd say, well, wait a minute. This next one, you've got a numerator for your fraction. You've got 7 to the 3/5. Well, what kind of a root is it, though? What number goes inside? It's a 5, right? It's the 5th root of 7 to the 3rd. So what you really, hopefully, are picking up here is this denominator tells you what kind of a root you have. It goes both directions, right? Here's something more abstract. X to the 2/3. What kind of a root is it? What number goes inside? A 3. It's a cube root of x squared, right? And then you're good. So you get used to this. You can do these fast. You can do these very quickly. Let's take a look at the back side, and they're going to say, look, we're going to go an extra step now. The directions are changed. We need to simplify. We're actually going to say, hey, it's not enough for you to just write it as a radical. We want you to do that. But you're going to actually have to break it down and simplify it. So first off, 25 to the 3 over 2, what kind of a root is this? It's a second root. It's a square root, I hope you're seeing. And you can think, well, how do you know? Guys, hopefully right now this is just becoming clear as anything. You can say, hey, that denominator tells you what kind of a root you have. And then you could say, well, here's 25. Now, like we said earlier, you could put the 3 inside the radical. I'm going to suggest that we actually move it outside. Now, if you move it inside, you'll get the correct answer even if you cube it. But here's the bottom line. What is the square root of 25? 5. It's just 5. And then you'd say, well, then I can raise that up to the third. 5 to the third. You can get help with your calculator, but hopefully you know that 3 5s multiply to 125, right? This next problem right here. You've got 16 to the 3/4. What kind of a root is it? It's a 4th root. It's the 4th root of 16, and then you can bump your 3 up. Now, here's where, if you were absent yesterday, we can show you real quickly how to get a 4th root on your calculator. So, you know, obviously you don't see a 4th root on the faceplate of the calculator. When you have to do higher roots, start with the index. This is a 4th root, so we can type a 4. Then, what we're going to do is we're going to hit math, and we're going to come down to the x root. And when you hit enter, you'll get the 4th root, and then very quickly you could figure out that that's a 2. The 4th root of 16 is a 2. So you could also have figured that out just by common sense. You could have said what number multiplied to itself 4 times is 16. You'll get that it's a 2. Finally, what's 2 to the 3rd power? It's really 2 times 2 times 2, and that would just be an 8. And of course, you could use your calculator to get help with that as well. All right.
So 8 is the answer.
8 is your final answer right there. Okay, now the next problem that you're going to see is if you had x to the m times x to the n, this is some review, you could see pretty quickly you're just going to add these exponents. So for 4a, what you're going to wind up doing is simply add 2/3 plus 5/9. Now, you could do this by hand. You could do this with a calculator as well. Look, it's real easy to get the calculator going here. You could say here's 2/3. We could say plus alpha y equals always gets you your fraction option. And here's 5/9. And it does not take too long to see that you get 11/9. Final answer is x to the 11/9 power. So when you have x to a power times x to a power, you will just add those exponents together. As you look down here at your part B, very similar setup. You'll just wind up taking 3/4 plus 1/2. And guys, from here, just go alpha y equals. And it's not going to take you too long. So many of you are probably thinking you could do this so easily in your head. Of course you could. If you've struggled with fractions in the past, though, there's nothing wrong with just getting some help here. Final answer will be w to the 5/4. Okay? Last problem of the day is really review from what we've seen in the past as well. If I gave you x to the m over x to the n, that could be reduced. We're not going to add those powers. We're going to subtract them. So when we see something like this, we'll have x to the 3/5 minus 3/4. Now, as we get some help from the calculator, we can definitely do that. We could say, well, let's do that. 3/5 Then we'll say minus 3/4. You can see that actually your answer in this case is going to be negative. It's going to be negative. You'll get x to the negative 3/20. But watch out. You want to write your answer as we read the directions here with only a positive exponent. Now, another thing that we learned earlier is that if you had x to the negative n, you guys remember what you got to do? You got to flip it, right? You're going to have to take the reciprocal. You always go 1 over. So what you would have to do to type this into Alex is just take that reciprocal, make a fraction show up, go 1 over x to the 3/20. Last one is really pretty much the same idea. We're going to have to subtract our powers. And again, this is where, a calculator can help you out. It could even be a scientific calculator. If you're good with subtracting fractions, of course, you can just do this, in your head. But nothing wrong with, especially during a quiz or a test, to double check your work, make sure you're doing okay. As you've got this out very fast, you'll get 1/10. Do I need to flip this? Do I need to take a reciprocal? No. You've got a positive exponent and you're done.